All right, let's talk about something that drives plastics professionals absolutely crazy: getting your color consistency right. If you have ever fought and fought to get that perfect shade, only to see it drift, well, you're in exactly the right place. We're going to break it down.
Does this sound a little too familiar? I mean, you've spent all this time getting the Masterbatch perfect, the formula is spot on, but what's coming off the machine just isn't matching up. It is one of the most common frustrations in the industry, but the reason why might actually surprise you. And here it is. This is the kicker. A massive 80% of color variation problems have absolutely nothing to do with a bad pigment or a messed up formula. Nope, they come from the process itself. And that one little fact completely changes the game. It shifts our focus from the what to the how. So, okay, if it's not the pigment, what's the real problem? Well, it turns out there are four main culprits we need to put under the microscope: heat, shear, pressure, and time. If you get any one of these wrong, even the best color formula in the world is going to fail you. So let's investigate them one by one.
Okay, let's kick things off with our number one suspect: temperature. It seems pretty obvious, right? Heat is a huge part of the process, but you'll see in a second how getting the temperature even slightly off can have a really dramatic and often disastrous effect on your final color.
You're kind of caught between a rock and a hard place here. If your temperature's cranked up too high, you're basically just cooking the material. The shade gets darker, you start to see that awful yellowing, especially with materials like ABS and PC, and any bright neon colors just turn dull. But on the other hand, if you run it too low, the pigment never gets a chance to mix in properly. You end up with a dull finish and those really ugly flow lines.
So what's the answer? It's all about stability and control. Just remember these three things. First, you have to know the specific heat limit of the pigment you're using. Second, keep those barrel zone temperatures as stable as you possibly can. And third, whatever you do, avoid sudden temperature swings. Consistency is the name of the game.
Next up, let's get physical. We're going to look at the actual forces happening inside that machine. We're talking about shear, which you mostly control with your screw speed, and back pressure. You see, these two forces work together to determine how well that color actually gets mixed into the polymer.
With screw speed, or RPM, it's a real balancing act. You need to run it high enough to create enough shear to get a really good pigment mix. But if you go too high, you can literally destroy delicate effect pigments, like the flakes in a pearl or metallic finish. And of course, if the RPM is too low, you just don't get the mixing action you need and you end up with a blotchy, patchy mess.
So here's a really simple rule of thumb you can use. If you're running just a standard solid color, go ahead and use a medium to high RPM. You'll get that great, thorough mix. But if you're working with those special effect colors, like a pearl or metallic, you've got to stick to a medium RPM. That'll give you the dispersion you need without shredding the flakes.
Now let's talk about shear's partner in crime, back pressure. You can think of it as a force that pushes back on the screw, and that resistance forces the material to mix much more intensely. It is absolutely essential for breaking up stubborn little clumps of pigment to get that perfectly uniform color. And you guessed it, it's all about balance. Too much back pressure creates way too much shear and friction, which builds up heat, and we already know what that does: it darkens the shade. But if you have too little back pressure, you're right back to where you started, with poor dispersion and visible little specks of unmixed pigment. Finding that perfect sweet spot is everything.
Okay, our last parameter is the one that people forget about most often: time. I like to call it the silent killer of color consistency because it does its damage slowly, quietly, right there inside the barrel.
So what exactly do we mean by residence time? It sounds pretty technical, doesn't it? But the idea behind it is actually super simple.
Residence time is just that. It's the total amount of time the material, both the polymer and the pigment, spends inside the machine's barrel. It's the entire duration it's getting blasted with heat, shear, and pressure, from the second it drops into the hopper to the moment it comes out the nozzle.
And why is this such a big deal? Well, think about it. If the material sits in that hot barrel for too long, the pigment itself starts to break down. You'll start to see yellowing, and if it's really bad, you'll get those dreaded black specks, which are literally just bits of burnt material. But if the residence time is too short, it's the opposite problem. The material shoots through too fast and doesn't have time to mix properly, leaving you with an inconsistent shade.
So we've broken down heat, shear, pressure, and time. Now, let's tie it all together. It's time to talk about the single most important rule you need to know to get consistent color every single time.
But before we get to the golden rule, let's quickly look at the most common mistakes that completely destroy color stability.
Things like running different settings in production than you did for the lab trial. Or, and this is a big one, letting different operators on different shifts use their own special settings. All of these things create an unstable process, which makes consistent color pretty much impossible.
And that brings us right to the golden rule. Seriously, if you only remember one thing from all of this, let it be this. First, lock the process. Then, and only then, do you adjust the color. Because if your process is always changing, you are just chasing a moving target. You will never ever achieve a stable color.
It all comes down to this: creating a standardized, locked-in process. And here's your checklist. Is your temperature stable and correct? Is your RPM optimized for the type of color you're running? Is your back pressure balanced? Is your residence time consistent? If you can say yes to these 4, you have just solved 80% of your color problems right there.
So now you've got the playbook for stabilizing your entire process. And once you have that stable foundation, you can start going after specific defects. So join us for our next explainer, where we'll use this exact knowledge to troubleshoot some of those common headaches, like black specks, streaks, and color patches. Thanks for tuning in.
That's all for day 13 of our color matching series today. Learn some important color matching concepts and practical tips that can help you improve your shade deployment skills. If you found this video helpful, please like, share and subscribe to channel. Follow CIPET Polymer Tech for daily learning on color matching, QC production and R&D in the plastic industry. See you day 14 with another useful topic. Thank you for watching.